So in this video, what I want to do is basically write a Fibonacci sequence algorithm in assembly. And I always found kind of like a barrier to assembly. I want to learn for a very long time, but I never could get started. So my intention in this video is to start from scratch, download an assembler, and write the whole program from scratch. And basically, I found it quite enjoyable that you can write programs in assembly, and it's not that difficult. So yeah, so let's start. Let's get started. So the first thing we want to do is, okay, of course, we have our editor. So I'm using IntelliJ IDEA. It really doesn't matter what you use, so use any editor you want. So, okay, so let's create our file. So what I want to do is create a file called fib.asm. So here I have my file. And here we're going to write our assembly code from scratch. So let's first download the assembler. So what I'm going to use is an assembler called Flat Assembler, rather FASM. And you can click the download link here. And then if you're using Windows, of course, go ahead and download this one. Not DOS, but the Windows version. And then once you downloaded it, what you can do is what I've done, just extract the folder like here, extract everything here, and then you can, that's it, you're good to go. And the only thing you need is, of course, make sure that your environment variable, the path is set, so that you can call fasm.exe to compile this the file. So I'll show you my environment variables, the settings I have. And you want to include this path so that you can call this, and you also want to include this include folder. The reason is because the assembly program needs to interact with the operating system to show the output. So we need to include one file called win32a.inc, and we want to also include this file training.inc, which basically what it does is it allows you to enter values and it shows values, prints out the value. So this entering the value in the console and printing it out is not easy in assembly. So we have this is like a kind of like a cheat, so that at least as far as training is concerned, you can overcome this hump. And by the way, this training.inc is not part of the flat assembler. So what this file that I have here, training.inc, I got this from this training course, zorpd.net. So the guy, zorpd.net, provides this file called training. And this file allows you to easily enter a value into your console program and print it out. That's all it does. Nothing more. So to get this file, we can just type zorpd training.inc. And yeah, this is the one you need for that, this file. Okay, so I hope you got the FASM installed, and you can download this and also put it in the include folder. And of course, as promised, my environment variables, I have this include variable, which is this include path. That's the include variable, and my path contains this FASM, where the FASM exe is located. So these are the two environment variables. One is the path FASM, and one is the include variable. This one that leads to the include path here. Okay, so that's it. That's as far as installation is concerned. We're done. Now we can start writing our assembly program. The first thing we want to do is tell the flat assembler that this is a console program. Okay, and then we want to include the file that helps us with the operating system. That it's a console program, that it should start in the operating system. So we need some instructions that basically interacts with the operating system. So this is the win32a inc. This file comes with the flat assembler. Again, yeah. So this win32a comes with the flat assembler. So That's it. That's the file you need to include. And one more, training.inc. So what training provides is, again, just basic input and output. That we want to type in a value and we want to print out a value. Okay, so that's as far as includes are concerned. Now we begin our program. So the entry point, let's mark our entry point. That's let's say entry start. So the start is basically the label we want to put. That's our entry point. Okay, and let's also mark our exit point. So for example, when we exit a program, we have to tell the operating system that yes, we're ready to exit. So we do this push 0, and then we call the exit process. And that's it. So we have a basic skeleton for our assembly program. So now what we can do is, if you look at, okay, I have auto-compiled it. So what, because of this setting here in my IntelliJ, that I auto-compile the file. So basically what I've done is, I'll just delete it so that I can show you what happened here in the background. Okay, so here I have my fib.asm. That's it. That's all I have. Now I run fuzing fib.asm, and it shows, yep, it compiled the file, 3 passes and all that. So now if you look, yeah, there's my fib.exe. Now if I run it, yep, it just runs. Fantastic. Because I'm calling exit process, doing push, and I've included Win32 ANC. Excellent. Everything is working as expected. As a matter of fact, if I just delete this training and yeah, and if I even delete this exit label, so all I have now is just the basic. Okay, so sorry, the exit process is also part of the training.inc, because that makes the exiting the console also easy. So that's my skeleton. That's all. That's all I have. And if I compile this and run it, yeah, my program starts and exits. That's it. Okay, so now let's begin. Let's start our program. So here basically what I've done is I've created an exit label so that I'm going to write some code here, and then I want to call this exit label so that I can properly exit. So to begin with, let's simply read a value from the user. So to do that, we use call, and then within training.inc there's an instruction, there's a label that reads a number from the input. So that's what we do, read hex. And once we read a value from the input, what will happen is the value will get stored in a register called EAX. So here's a super crash course on assembly registers. This is really basic. I'm skipping over a lot of stuff. So imagine we have 4 registers. An assembly program. These registers, the ones that I'm going to write particularly here, are 32-bit registers. So it contains 32 bits. In other words, 4 bytes of value. Yeah. Okay, so here is one register called EAX. Now I'm going to draw another one. I'll call that EBX. Then draw another one. And let's call it ECX. And finally, one last one. I'm going to call it EDX. So I'm going to use these registers basically to write my program. Okay, so let's start with EAX. All right. So read hex. What that will do is whatever I input, it will put it in EAX. And now all I want to do is just print it out. So I'll call again. And this instruction set is also included in the training.inc. So basically what I'm typing in, I'm just going to print it out. So again, my file auto-compiled in the background because I have this this thing in IntelliJ. Otherwise, all you do is just type chasm fib.asm. Okay. So now if I run my program, so it's waiting for me to enter a value. So let's say I enter 5. So if I press enter, what I should see is just 5 being printed out there. So I entered 5 and just 5 was just printed out. Nothing more, nothing fancy. Simple. That's it. Okay. So now I have my input value. So what I'm going to enter is the highest value of the Fibonacci number that I want to write a sequence for. Okay. So let's slow down a bit. What is the Fibonacci formula? The Fibonacci formula states that one second. Increase my font size. Basically what it does, it states that the value of x and y should be, let's say if it starts with 0 and 1, then for each Fibonacci loop, the value will become, the 1 will shift here, and whatever x was, it will be the sum of that. So xy will become, x will become y, and y will become the sum of x and y. So for each loop, we will be writing this sequence. We'll be adding the numbers x and y, and x will become y, and y will become the sum of x and y. So that's the sequence. That's the first sequence. And the second sequence, it will keep running. So that's how we'll get our Fibonacci sequence. So now what we want to do is, of course, we've read hex, and so the value that is in hex is in the register EAX. So now what we want to do is we want to use this EAX basically as this is the strategy. I'm explaining the strategy. In the register EAX, we want to use the register EAX as our x variable that we see here, and we want to use EBX as our y variable, right? EAX we want to use as the x variable and EBX as the y variable. The ECX we want to use this as our counter. So that let's say I enter the value 5 and I would want to go 5, 4, 3, 2, 1. So I want to keep track of my counter, and I'll use the ECX register for that. And for EDX, I want to use this as my temporary variable or placeholder, because here I'm going to do a swap. So right here, I'm going to swap the x for y and the y for the sum of x and y. So to do this swap, I need a temporary variable. So I'm going to use EDX, the register EDX, as my temporary variable. So now let's get coding. So to test it out, let's do a simple thing first. Let's make sure that we're looping the number of times that the entry that we make as our counter, so that will become our counter, and make sure that we're looping and we're exiting the program after the loop. So to do that, let's say we have create a label fib, and what we want to do is when we read the hex value, we have the EAX value in the input in the EAX register, and what the input is in the EAX register, we want to initially put that in ECX register. So we say move. The destination is going to be ECX, and the source is going to be EAX. So whatever is in EAX, we move to ECX, and then in our sequence, we decrease ECX, and what we want to do is we want to watch in the jump zero in the zero register. The zero flag. We want to check that the counter goes down, and as soon as it goes down to 0, we want to make a jump here to exit. Otherwise, if that doesn't happen, we just want to loop forever. So we say jump to fib. So this goes back to here. So again, we're decreasing ECX, what we just entered, and if that value reaches 0, we want to jump here, exit the program. Otherwise, what we want to do is we want to go back to our Fibonacci sequence. Okay. So now we're storing, we're doing our decrement in the ECX register, and let's say we just want to see what happens. We want to make sure that it becomes 0. So what we can do here, just for testing, we can do move the value of ECX into EAX, and we could I don't know, we could print out every time we're looping here. So to do that, again, we have to copy this whole thing and paste it here just to check that we're actually decrementing one by one. So yeah, we can do a 1000 fib.asm and then run it. Okay, so let's say 5. So now what should happen is we should see it just decrementing 4, 3, 2, 1, 0. Oops, that didn't happen. Okay, sorry about that. So let's see why that didn't happen. Okay, typo. ECX. ECX. Yeah, let's try again. Compile and run. So let's say 5 of them. Oh wow, now we have an infinite loop. What are we doing wrong? Okay, let's take a close look. ECX, the value of ECX is going to, the EAX is going to ECX, and then we're moving the value of EAX to ECX, which we already did there. Okay, so we want to print it out. So to print it out, actually what we want to do is, okay, here we also did a mistake. It should be we only want the value of ECX to go into EAX. And here we decrement ECX, and then we just want to print out what happened before the jump, if the jump doesn't occur. So yeah, move the value of ECX into EAX and just print it out. So let's try running it again. 5. Okay, perfect. So we got 5, and what happened is we're seeing that, okay, whatever this, our loop is working, our loop sequence is working. That we're decrementing ECX here, and if it reaches 0, we'll just jump here. Otherwise, we're just going to print out whatever we have in ECX. We can't print out ECX directly, so that's basically the reason we're moving the value of ECX into EAX. That's the reason we have to do this step. We can't just print ECX. We can only print EAX. All right, so let's try another test. Let's do maybe 9. Good. So our loop sequence is working. So let's now simply move on to our Fibonacci code. All right. So here's our counter. Here we're setting our counter. And now what we want to do is set our X and Y variables, basically. So we want to set EAX to 0, and we want to set EBX to 1. This is the part with what we just did, EAX, and we set this, basically. X and Y, basically, the EAX register and the EBX register, we set it to 0 and 1. All right, so that's the initial part done. So now, here is our Fibonacci code. So we want to create a temporary variable where we store the variable, where we store our the value of X. So we can do move EDX. That's our EDX is our temporary register that you can see here. That's our EDX. So in EDX, we store the value of EAX, our X variable. Okay, and now what we want to do is we want to put this the value of Y. Oops. We want to put the value of Y here. Okay, therefore, what we will do is we'll do a move destination EAX and our value from the Y register, which is EBX. Okay, and now what we want to do is we want to put the content of our X and Y into Y. So for that we do our add. The destination is EBX, and we want the temporary value that was there in EDX. So whatever was in EDX now gets added to EDX. So this 3 lines is basically our Fibonacci algorithm. Now we decrement ECX, and we check for that. If it reaches 0, we exit here, the test that we already did. And we don't want to, we don't need this. This was basically our debugging. We wanted to check if it looped down. And that's it. We should be done. That's it. That's all there is to it. That's our Fibonacci algorithm. And the code already compiled in the background, but I can do it again for you. All right. So now let's test it out. So let's look at some Fibonacci sequences. Let's look at this. All right. So Fibonacci of 5 should be 5. So let's try 5. Oops. All right. So what happened here? What happened here is that and from the previous year, we were basically printing our the loop increment, the decrement variable in the ECX counter. We don't want to do that. What we want here is basically just nothing. We just want to print whatever is in EAX. We don't care about the loop variable anymore, because the EAX is the X value. The EAX is the X value, so it will contain the sum, the Fibonacci sequence, the sum of the Fibonacci sequence. So let's come here and let's recompile. So let's try 5. Yes. So 5 gives us 5. Let's try 9. Fibonacci of 9. 9 gives us 22. So that 22 is in hex. So let's bring up our hex calculator. So let's type in the value 34. So this should give the hex value 22, because what the assembly does is it gives us hex numbers. So we want to type in decimal. Fibonacci of 9 is 34. So we want to type 34. So in hex, that's 22. And there it is, 22. Awesome. So let's try some big number like 15. So 15 in decimal is, let's just type it this in decimal. 15 in decimal is F. And we're reading hex here. So we want to type in F. That's 15. And the answer is 262 in hex. So let's say 262 in hex is 610. And 15 is 610. Awesome. Now let's try one big one here, like 19. So 19 in decimal would be 13 in hex. So 13. That gives us 1055. So let's type in 1055 in hex. 1055. So that gives us 4181, which is exactly what we have here. All right, that's it. I hope you enjoyed this video. And one last thing we can do, that is because the registers are size 32 bits, so 4 bytes. So there's a maximum number it can contain. So what we can do is that if it reaches the max capacity, we can just exit the program and say, okay, here's a value, and this really doesn't. We already reached the end, so we don't get false values, because what will happen is if it exceeds the capacity of the register, it's just going to wrap around. It's not going to throw an error. It'll just wrap around and start from the beginning. So we can do a test here that after it adds, we can watch for the carry-on flag. So we can say if the carry-on flag gets set, we want to simply get out of this loop. And so for that, we can create another flag here, label here called, let's say, fib carryover, or just carry. And what we want here is basically, we just want to say, hey, EAX now has some value that really doesn't make sense. So like some carryover occurred here. And then we just want to jump to exit. Actually, basically, it will just fall through, so we don't really need to type jump exit. It's just going to fall through. Good. Oops. Yeah. So here, what we're watching is if a carryover occurs, we just want to exit the program. We want to go to carry. We don't want to carry out the sequence. We just want to come right here and put some kind of -1 value here. So basically what it will do is it just print all F's, and then yeah, that's so we'll then basically exit our program. So let's save, let's compile, and let's run. So here basically what will happen is the highest value that we'll reach here is basically 30 hex. So we can test it. Oh, I was running this program while I tried to compile. All right, so let's run it again. So for 20 hex, so far so good. For 25 hex, excellent, so far so good. For 28 hex, okay, that works fine, no wraparound. 29 hex, no wraparound, everything is awesome. And then for 30 hex, yeah, we get this all Fs, which is basically we're saying a carryover occurred here, and that's the highest we can calculate for 32-bit registers. Okay, so that's it. Thank you for watching. I hope you enjoyed this video, and simply have a great day.